Hello everyone, welcome back to .NET Empire. As always, I'm your Venkatesh. In our ongoing learning path of video series, we have already covered our very first building block, that is basic prompt. In that video, we have covered how you can actually create these basic prompts within the semantic kernel and use them in a different ways. So it really depends on the requirement that you are actually supposed to do. Along with that, we have seen the streaming mechanism offered by the OpenAI within the semantic kernel. By using that, how you can actually improve your user experience. In this video, we are actually going to see another crucial building block of the semantic kernel, that is kernel functions. This video, we are going to see how you can actually create these kernel functions and use them with a real-time example. Without wasting time, let's get into the code.
Wait a minute.
Before we actually go and create these kernel functions, it is very important to understand what are the problems that these kernel functions trying to solve for us. Now let us actually see the challenges that we are facing with the LLMs. Suppose imagine you are asking a question to LLM that who won the yesterday's match between the CSK and LSG. Obviously you can't expect the answer from the LLM because these LLMs were trained on a data up to certain point of time. So it can give you answers on the activities like which just happened yesterday or sometime before. To solve this, OpenAI has come up with a specification called a function calling. Using this function calling, you can actually make your external APIs or data sources available to the LLM so that whenever and wherever it requires some additional data out of its own knowledge, it can actually go and pick the data to give you the right answer. This is what the semantic kernel functions actually going to use behind the scenes. Now, the advantages of using the semantic kernel for using the function calling is you don't need to actually write down everything to suit with that function calling specification. So semantic kernel team will manage everything behind the scenes. And also the another big advantage of using the semantic kernel is you can choose your own language which is offering by the semantic kernel to create the functions. So you can create your native functions and then attribute them so that LLM can use those as a function calling features. So let us see in action how we can use this kernel function to solve such kind of issues. For today, I just prepared simple example to demonstrate what is that challenge that we are facing with the LLM. To show you, I just used the same technique what we have already have seen in our last video. So I just prepared the semantic kernel builder and then created the kernel out of that. All the things have I just prepared in the same way. And then I'm asking question to the LLM that what's the time now? Let us see what the LLM will respond back. If you notice this, the LLM is clearly saying that it can't help with the real-time data. This is the problem that we are going to solve now using the kernel functions. Now let us see how you can get our current date and time using the C sharp. In order to get that, you have to use this date time and now property. And to make it more readable, you can use one of the overload version of the toString. Let me show you actually what it will give you back. For that, I'm just using the C sharp interactive present in the Visual Studio without running our actual code. Now, let me write down simple right line and this. After running this snippet, we are getting current date and time in this format. So it is more readable now. We just created our C sharp method, which will give you current date and time in a string format. But you have to convert this C sharp method to a kernel function. Then only LLM will be able to invoke this where and when it is required. To do so, you have to use couple of data annotations and attributes provided by the semantic kernel SDK. So to convert any of the C sharp functions, you have to use the kernel function attribute, and also you can provide the name for the kernel function. Then, as I have mentioned before, you have to clearly describe the couple of specification for the kernel function. Then only LLM will be identifying the right function for the right actions. So I'm describing when to use this kernel function, and also I'm describing what the LLM can expect after this got executed. Yes, we just created our very first kernel function here. Now it's a time to actually use this kernel function in our example. To do so, you have to register the function which you created with the kernel. Let us see how you can do that. So you have to use this kernel object which we created earlier, and then there is a method called import plugin. There are multiple ways to do that. For now, let us use our last method where we can define our class name where our kernel function is actually available. So what is our class name? It's our time plugin. So with this line, we are actually registering our time plugin class into the kernel, and semantic kernel is able to figure it out how many kernel functions are available in this class. Now let's see how you can actually invoke that function. To do that, again, you have to use this kernel object. Inside the kernel object, there is a method called invoke async, and you can also mention the output type here. So yeah, I mentioned the string as output type, and there are multiple overloads for this method. We are going to use our second overload where you can mention the plugin name and function name. You might be wondering from where this plugin name is coming. It is nothing but our class name. So let us give our plugin name here, time plugin, and then the function name. So you know that we just created a kernel function with this name. That's all you have to do. Now let us store this somewhere. Function result. And since it is a asynchronous call, let us use await as well. Okay, let us print this function result here after this executed. Let me run this to show you the response back. So you might be wondering where we are actually asking a question and how this kernel is using the function. We are not actually doing anything. Explicitly mentioning the function name for now. And later we will see how you can make this calls automatic as well. So if you see, the first invoke prompt async has give you this answer that we already know. Now the second function, even if you're using the invoke async, the LLM is figuring out, oh, it has to go and ask this function to get our current date and time. This is what it gave you back. Now let us see how to make it automatic so that you don't need to specify this function name explicitly. It looks LLM is still not able to identify which function has to call. There is some problem with our code. Let us fix it. I guess we need to pass on our kernel object as well. Yeah. Yeah. With this change, let us execute again. As you can see now, the LLM is successfully able to invoke that function automatically and give the response back. The current time is 6:35 p.m. on Saturday, April 20 and 24. This is how you can solve the problem that LLM is having. So you can create number of kernel functions for different reasons, and so LLM will be able to use those kernel functions depends on the question that we are asking. But if you're wondering, hey man, there are a lot of things are happening behind the scenes, and how we can actually debug that one, how we can actually understand what is happening behind the scenes. In order to do that, there is a settings that you can enable to see a step-by-step process what is happening. Now you have understood that the importance of the logging so that it will help you in a production scenarios how to debug for a particular wrong answer. Since I am using a console application now, I have to install one NuGet package. This is the NuGet package that I have installed here. Once this NuGet package got installed, you have to write down one line in the kernel. So let us see how you can enable the logging. If you see already I have put this line where I am adding the logging to the console. Why I'm not still getting the logging here? Because I set the log level to none. But let me enable this to trace. With these simple settings, now you will be able to see complete step-by-step process what is happening behind the semantic kernel. Let me run this function again to see everything in action. If you see, now we started seeing a lot of things are happening behind the scenes. If you just see here, we are actually getting the step-by-step process what is happening behind the scenes instead of just the responses that we have seen before. So we are using the Azure OpenAI chat completion service, and the LLM is figuring out what function it has to call. This is the function that it identified. Then it has got these results back from that C# function. Then it is actually synthesizing and giving you a final answer here. So this way you can actually debug step by step process. I hope this session was so helpful to you, and if you like the content so far, please make sure you subscribe this channel and like and share with other folks too. And thank you for watching this video, and I will see you in the next video. Bye bye.